Hey everybody, my name is John Broadwell. I'm an embedded systems and medical device development consultant at my company, Broadwell Consulting Incorporated, that also created the open source Serial Wombat project, which is currently the subject of a Kickstarter campaign for our latest board and firmware, the Serial Wombat 8B. I'm excited to announce that the Serial Wombat 8B's headlining board, the most straightforward one, is now a certified open source project through the Open Source Hardware Association. And what that means is that I've gone through a series of steps to prove to this organization that the software and that the firmware and documentation and hardware are available in a format where others can take it and easily modify it. I'll be talking to the Open Source Hardware Association on their stream on April 17th, live at 1 p.m. Eastern Time. There's a link down below if you want to be able to tune into that stream, so check it out if you like. And when you get this certification, you commit to continuing to make that available, even under penalty from them of, in the worst cases, financial liability should you renege on your commitment to the open source nature of the project. So, this is the strongest of the promises you can make to have an open source project. And this is really important. People tend to think of the open source hardware of, I want to be able to access and change the schematic or the board or whatever. But even having direct access to the engineering artifacts of an open source project is important. And we'll take a look at that today. When I create projects and products for people, I try to fix all of the things that annoy me before I ship them so they don't annoy you. One of the things that's been annoying me lately is I've been soldering a lot of 8-pin headers into the Serial Wombat 8B boards, and getting them lined up just right is annoying. And you can put them in a breadboard to do it because they're spaced at 300 mils, but then the breadboard sinks heat out of your pins, which makes it harder to solder them, particularly the one that's attached to the ground plane, and so I didn't want that. So to fix this annoyance, I created this 3D printed design which aligns the pins, lets you set the board on top, and easily solder it in. And it works great. No worries about the PLA melting during the relatively quick soldering process of the pins or anything like that. So and I wanted to basically show you how easy it was to create this because I have access to the CAD files, which you also will have access to because it's an open source design, so you could do something similar if you wanted. So if you get a chance, hop on over to the Kickstarter and back the project. I'd really appreciate your support. And now let's take a look just real quick at the steps I went through in Fusion once I had this 3D board, which you have access to create this soldering block. First, we'll turn off all the layers except for the FR4 so that all we get is the actual board hole outlines when we go to do a projection in a minute. Then we'll create a new external component in the assembly. Next, we'll make a sketch on the board plane and then project the pinholes so that we can use them once we extrude out from here. Then we'll extrude the block down 7 millimeters because that's how much space we need in order to be able to drop the pins into the holes. Next, we'll do a couple of millimeter thin extrude around the outside of the block so that we can create the little enclosure that will hold the chip in its proper location. We'll set the height of this extrude so that it comes up just barely below where the top of the FR4 would be when we go to solder the pins in so that we don't interfere with the soldering iron with the plastic. And I turned my camera off, so I missed this part. But the other thing we'll do is we will go on each of the holes that you drop the pins into and the inside of that lip and add a 0.7 millimeter offset. That's what's appropriate for my 3D printer. Yours may vary, so that everything is big enough and everything fits. In a case like this, it's better a little too big rather than a little too small. Things may wobble a little bit, but at least they'll fit. So, and at that point, we're ready to 3D print it. So there you have it. You can see how easy it is to take somebody else's open source hardware and quickly create your own accessories or jigs, tools, whatever. It's really important. If you have a project of your own, I would highly encourage you to get it to be certified open source hardware. Until we talk again, have fun, keep making stuff.